Hello Internet. I am going to show you a solution to beginner series number 5 triangular numbers. Now this is not a good solution in that it's wildly inefficient. It does a ton of calculations that it turns out there are other solutions that don't need that, but if you want to do that, I'll leave it to you to figure out the clever, efficient solution. This is the inefficient, brute force solution, but I thought you still might find it interesting to see this approach. So let's start by, I'll introduce the problem. This is a 7Q Codewars Kata, that is a challenge on the website Codewars. Beginner series number 5, triangular numbers. In the details, triangular number is the amount of points that can fill an equilateral triangle. There's some grammar issues there, but I'm going to move on. For example, the number 6 is a triangular number because all the sides of a triangle has the same number of points. I wonder if I can edit this and suggest changes. Anyway, there's a nice little picture, 1, 2, 3, 4, 5, 6. A hint, we have a formula, I'll come back to that later. Now given a number t, in the interval t is 1 to 2, 1, 4, 7, blah, blah, blah. I'm not sure the significance of that number, but it might be, it might have to do with the number of bits in storing a integer number. Not sure about that, but maybe. But that's not important because this is Python, and Python takes care of things like that for you pretty much automatically. Well, so full disclosure, I've already worked through this one. This is my repeat. I won't even say attempt. I'll just say I'm doing it to show you how it works. So try again. Here we go. Now, the way I approached this one is I said, well, what if we just checked a bunch of numbers, or rather, what if we took the number that it gives us and checked it against all of the triangular numbers? Well, that's a nice thought, but how many of the triangular numbers would we have to try? Well, I'll come to that. But I'm just going to create a while loop that's always true, and you'll see that I'll include a condition to break it later. But while true, let's just imagine that we have a function that calculates t as a function of n, and I'll bring the n in later. No, I'll bring the n in now. Say n equal 1. Let's say if t of n equal to t, and you can imagine that we're going to need at some point to iterate. We're going to need to iterate n up by 1. I'll come back to that later. So again, we have for each n, we calculate the triangular number with the side of n, and if that's equal to the target triangular number, then we return true. After we check that, we iterate by 1. But the problem here is this, as it's currently written, would go on forever. In fact, if I do test, it'll probably time out on me. Oh, I haven't even defined t. Well, I'll just do something fake here. Let's check that this times out, which is what I expect it will do. Of course, we're going to have to wait a little bit for that to happen, but execution timed out. Okay, 12,000 milliseconds. Okay, that's as expected. So obviously, I need to add something to this that will cause it to stop. And the way we know that it's time to stop is if we get to a triangular number that's greater than the target number. So what does that look like? Well, for one thing, I'm going to have to actually use the t of n result twice. So I'm going to store it to a variable so I don't have to calculate it twice each time. Candidate t equals t of n, and we still, remember, we're just assuming that we have a function t of n that calculates a triangular number as a function of n, where n is the size of a side. Okay, if candidate t equals t, return true. Else if candidate t greater than t, that's our target t, so it should be the case that we either end up returning true or returning false in every case. So this while true loop, it will actually terminate, assuming well-behaved input, which I happen to know for this particular Codewars challenge, Codewars Kata, there will be well-behaved input. And even if it did fail to terminate the loop, it would time out after 12 seconds. So I'm not terribly concerned about, being careful about these things. Anyway, the final thing that I need to put in here is that, do we have our function for t? Obviously, we don't have that right now because I just put a fake something in here. But luckily, all I have to do is copy paste the formula I've been given. Return n times n plus 1 divided by 2. Notice that this is multiplication and division, so the order doesn't matter, and we don't need to draw in additional parentheses. And if I haven't made any mistakes, I think this thing's ready to go. Yeah, it passed. And look, it didn't even really take that long. It took a lot longer than it could have done, 625 milliseconds. I don't know how long it would take in the actual case, but let's try it, the full one now. Huh, 577 milliseconds, even actually shorter with more trials. That's interesting. Okay. Now I'm going to also continue on through the submit button and show you how simple the clever solution is, because this was the dumb solution. This was the inefficient brute force solution. So I have to submit to get there. Well, look at this. We just have okay. So they took the remember this formula, t of n is n times n plus 1 over 2. Well, if you did some algebra, you'd find that it looks like you would find, anyway, do some algebra. Oh, I see. Yeah, do some algebra, just taking the square root over to the other side, and then check if t is equal to I actually would have to think about this one a little bit more, why that worked. But as you can see, I stuck with the dumb solution because I didn't think through the math closely enough to come up with something like this here. Okay, thanks for watching.